Hey everyone, and welcome. Today, we're jumping into one of the absolute most important ideas in AI right now, Retrieval-Augmented Generation, or as pretty much everyone calls it, RAG. You know that feeling when you ask an AI a question and it just makes stuff up? Well, if you've ever been frustrated by that, RAG is the really smart fix you've got to know about. All right, let's get into it.
So let's just imagine for a second. You go to a really powerful large language model, an LLM, and you ask it a super simple, timely question. Something like, hey, who won the NBA Finals last week? Seems easy enough, right? You're just looking for a simple answer.
But what you get back is, well, it's an answer that sounds super confident, perfectly written, and is just completely wrong. Maybe it tells you who won last year, or even crazier, it just fabricates a result from scratch. This isn't just some small bug, you know? It's a behavior called hallucination, and it's seriously one of the biggest roadblocks for us to really trust AI with the important stuff. And that really gets to the heart of AI's big, annoying problem. How can these models that are so brilliant, that have been trained on basically the whole internet, get such a basic, recent fact totally wrong? Well, it all comes down to a few core limitations in their design. It pretty much boils down to these four things. First up, the knowledge cutoff. An LLM is like a photograph. It's frozen at the moment its training stopped, so it has no clue what happened yesterday. Second, there's the private data gap. It doesn't know anything about your company's internal documents, your private emails, your code. It's a total stranger to your world. Third, like we just saw, hallucinations. Models are built on probability, so to fill a gap in their knowledge, they'll just invent an answer that sounds plausible. And last but not least, they can't tell you where they got their info. There are no footnotes, no source citations, and that makes it almost impossible to trust or verify what they're saying. So yeah, they're incredibly smart, but they're also fundamentally flawed. So, how do we fix this mess? Well, the first big idea people had was something called fine-tuning. And I love this analogy. It's kind of like sending your AI model back to school for some very specialized intensive training. So you've really got two main ways to teach an AI new tricks. Fine-tuning is the first one. And with this method, you're not just handing the AI a textbook. Oh no. You are fundamentally retraining its brain, baking your own specialized data right into the model itself. The idea is to make it a true expert in your specific field, whether that's legal contracts, medical research, or just your company's product docs. But this whole back-to-school idea, it comes with some major headaches. For one, it is insanely expensive. It takes a ton of computing power, which costs a lot of money. It's also not something you can just do with a few clicks. You need some seriously skilled AI engineers. And what if your information changes? Like a new policy doc comes out tomorrow. You have to do the whole expensive process all over again. And the kicker? Trying to get a model to forget old information is a total nightmare. So fine-tuning is powerful for sure, but it's often way too slow and pricey for the real world. And that, my friends, brings us to the hero of our story today, Retrieval-Augmented Generation, or RAG. It's a much more clever, way more flexible approach that just neatly steps around all the problems we saw with fine-tuning. I love this quote from IBM Research because it just nails the concept perfectly. Think about it. Fine-tuning is like cramming for a final exam where you have to memorize everything, a closed book test. RAG, on the other hand, is an open book test. We're not trying to force the model to memorize anything. We just give it the book, the right information at the exact moment it needs it to answer the question. Simple, right? So here's the more official definition. RAG is a system that makes a large language model better by connecting it to your own knowledge base. The key here is that it retrieves fresh, relevant info in real time and just hands it to the model for context. It grounds the model in actual facts without ever changing the core model itself. Okay, so how does this whole thing actually work? The best way to picture it is to imagine we're building a super high-tech, perfectly organized library just for our AI. The whole process really breaks down into two main phases. Phase one is all about building that library. The technical term is indexing, and this is all the prep work that happens behind the scenes. First, you load your data, all of it. Your PDFs, your emails, your company wikis, everything. Then you chunk it. The system chops up those long documents into smaller, bite-sized paragraphs. Think of them like little index cards. Now here's where the real magic happens. Each one of those little cards gets embedded. It's a fancy way of saying it's turned into a string of numbers, a vector that captures its actual meaning.
You can think of it like a unique GPS coordinate for that specific idea. And finally, all those GPS-tagged index cards get stored on the shelves of our high-tech library, which is actually a special vector database, all organized and ready to be searched. Then you have phase 2, which happens instantly, right when you ask a question. First, your question also gets turned into one of those GPS coordinates. The system then zips over to the library and does a search to find the index cards whose coordinates, whose meaning, are closest to your question. Next, it augments the prompt. It takes your original question and bundles it together with the information from those top matching index cards. Finally, this new supercharged prompt gets sent to the LLM. So now the model has all the factual context it needs right there in front of it to give you a smart, accurate, and fact-based answer. It's like an expert with an open book. So now that we see the mechanics, let's go back and really understand why RAG is such a massive game changer, especially when you put it head-to-head with that old back-to-school fine-tuning method. This chart really tells the whole story. Let's look at cost. RAG is way, way cheaper. What about speed? Well, fine-tuning can take weeks to retrain the whole model. With RAG, you can add a new document to your library in seconds. That means your data is always up to date, not stale. And maybe the biggest one, trust. With fine-tuning, the knowledge is just mysteriously baked in. With RAG, you can literally show your work. You can cite the exact documents used to create the answer. This massively cuts down on hallucinations and makes people actually trust the output.
So to wrap it all up, the benefits here are just huge. RAG gives your AI access to real-time private data. It builds genuine trust because you can cite your sources. It's way cheaper and easier to manage. And the big one, by grounding the AI in facts, it just crushes the hallucination problem. This is exactly why RAG is becoming so essential for any serious real-world AI application.
Now, RAG is already completely changing the game, but believe me, we're just getting started. The tech itself is moving so fast, so let's take a quick peek at what's just around the corner.
The next huge leap is something people are calling agentic RAG. So instead of just a simple lookup and answer process, you have these smart AI agents that are more like a research team. They can figure out the best way to ask the question, decide which data sources to check, look at the information they get back, and actually evaluate if it's any good, and then reason about it before giving you an answer. It's a huge step up.
But I want to leave you with one final, kind of mind-bending thought here. RAG is amazing at connecting an AI to facts, but what happens if the facts in its library are misleading to begin with? For example, there was a case where a model found a book with the sarcastic title, Barack Hussein Obama, America's First Muslim President, and because it lacked context, it just stated that as a fact. It's a perfect reminder that even with an open book, understanding nuance, context, and intent, well, that's the next great mountain for AI to climb. Thanks so much for joining me.